Hi, welcome to a video podcast on total internal reflection. In the previous video podcast on refraction, we considered a ray bending towards the normal as it went into a material where the waves were travelling slower. We're now going to consider the opposite case, which is waves travelling into a material where they're travelling faster, and we will get a bending away from the normal. So obviously we're always going from material 1 to material 2, and if the waves in material 2 are faster, the refractive index must be a smaller number. So n1 must be greater than n2 for this bending away from the normal and for total internal reflection to occur. If we imagine a ray that's coming in at a slightly larger angle, we can imagine we would get an angle of refraction of 90 degrees, and we couldn't have an angle of refraction larger than that, could we? You can't get larger than 90 degrees. You can't have sine theta being greater than 1. So if a ray has an angle of incidence of greater than this angle, it can't be refracted, it will all be totally internally reflected. So we can say that this angle here on the green ray is the critical angle. So any ray hitting an angle greater than the critical angle will undergo total internal reflection. And we can now calculate from n1 and n2 what that critical angle will be. So we start off with Snell's law. n1 sine theta 1 equals n2 sine theta 2. And the theta 2 in this case is 90 degrees and sine 90 is 1. So that simply gives us that n1 sine theta 1 is equal to n2. In this case, sine theta 1 is the critical angle, so sine critical angle is simply equal to n2 over n1. I hope you find that useful. Thank you.